Welcome everyone, my name is Dohwan from Korea University. Today I'm gonna present our work titled Bidirectional Likelihood Estimation with Multi-Modal Large Language Models for Text Video Retrieval. Let me begin with the task of text video retrieval. There are two subtasks in text video retrieval, text to video and video to text retrieval. These are examples of text to video retrieval. We are given a set of candidate videos and a text query, and the goal is to retrieve the video that matches the query. Recently, multimodal large language models, or MLMs, have been adopted for this task, leading to more accurate retrieval results. However, we found a key problem. These models often exhibit what we call candidate prior bias, where the model favors the candidate with high prior probability rather than semantically relevant to the given query. For example, in text-to-video retrieval, when given a set of videos, the model tends to favor the temporally static videos rather than temporary dynamic videos, regardless of whether it truly matches the text query. This bias arises because the MLM inherently assigns a high prior probability to the temporally static video due to its autoregressive nature. Therefore, the temporally static video with high prior probability mostly retrieved by text queries rather than focusing on semantic alignment between the text query and video candidates. We observed a similar phenomenon in video to text retrieval with text candidates. The MLM-based retrieval system often prefers the text with more repetitive or verbose phrases, even if the text is not relevant to the video query. In this case, the text with repetitive phrases exhibit higher prior probabilities than others. This suggests that MLMs are not simply matching semantics but are over-relying on prior probabilities of candidates due to candidate prior bias. This is an inference procedure of video to text retrieval showing how candidate prior affect the retrieval result. Finding the most relevant text from the given video query with candidate likelihood estimation is influenced by the both query likelihood and candidate prior. We observed that the query likelihood is relatively accurate retrieval result. However, the undesirable influence of candidate prior distorts candidate likelihood estimation. To address this issue, we propose a BLiM, which stands for Bidirectional Likelihood Estimation with MLMs. The idea is instead of only considering the candidate likelihood, we also consider the query likelihood. During training, we jointly optimize both candidate likelihood and query likelihood, ensuring that the model learns from the both directions. Specifically, the model is trained to generate the text sequence given the video, as well as generate the video clip sequence given the text. At inference time, BLiM combines both likelihood. For example, in video to text retrieval, we compute the likelihood of generating the text given the video and also the likelihood of generating the video features given the text. By combining these two scores, BLiM better captures true semantic alignment instead of relying only on candidate priors. The same principle applies in the opposite direction. In addition to BLiM, we introduce candidate prior normalization or CPN, which is a plug-and-play score calibration module. The idea is that as candidate likelihoods encode not only relevance but also prior biases, CPN normalizes the effect of candidate prior from candidate likelihood to reduce dependence on such priors. To compute prior probabilities, we apply attention masking strategies by masking the condition modality as is illustrated in this figure. For experiments, we evaluate our method and for text video retrieval benchmark datasets. Both on zero-shot and fine-tuning settings, BLiM outperforms the previous state-of-the-art retrieval model in term video 2 by a large margin. We also conducted evaluation studies to better understand our method. We found that using only candidate likelihood performs poorly due to bias, while using only query likelihood works better. The best results come from combining both, which validates the effectiveness of BLiM. When combined with CPN, the performance improves even further, confirming its role as a simple but powerful calibration module. In qualitative results, Bidirectional likelihood estimation successfully retrieves the ground truth candidate from the given query, while the candidate likelihood estimation tends to retrieve incorrect candidate that disregard the content of the query. We also find that tags with high candidate prior probabilities tend to be longer and contain repetitive phrases due to the deterministic nature of LLMs. Surprisingly, we can see the high correlation between prior probabilities and the text length and number of repeated phrases. To conclude, first we identified the issue of candidate prior bias in MLM-based retrieval. Second, we proposed a BLiM which combines query and candidate likelihood to mitigate this bias. Third, we introduced CPN, a plug-and-play module that further improves the performance. This is the end of the presentation. Thank you for your attention.